Hi there. Today we're going to do some adding and subtracting of rational expressions. And before we get started, I always feel like it's probably necessary for us to go back to the 5th grade here and remember how do you add and subtract fractions. To add and subtract fractions, you have to have a common denominator. So let me just throw a couple out here. You just need to watch. You don't need to write these down. But let's say you have 3/5 plus, let's say, 2/3. Okay, in order to add fractions or subtract fractions, you have to have a common denominator. So you have to come up with a number that both 5 and 3 will go into. And then you try to get the least common denominator, the smallest number that they will both go into. And so in this case it would be 15. All right, so what you do, once you figure out what they both will go into, then what you're going to do is you're going to say, well, to turn this 5 into a 15, I need to take it times 3. But I have to take it times 3 on the bottom, but I also have to do it on top. Because what I'm really doing is I'm multiplying by 1, but I'm calling it 3/3. And so that's why you got to do it on the top and the bottom. Multiplying by 1 won't change that number. It just changes it now to a 9/15, which is equivalent. All right, over here I have to decide what do I need to take 3 times to get that common denominator. So I need to take it times 5, but I have to do it on the top also. So it's plus 10/15. Once you're able to write this with the common denominator, then you go ahead and you add your numerators across, but your denominator that you worked on stays the same. So you're going to have, you're going to have a 19 over 15 as your final answer. All right, so now this one was kind of nice because the 5 and the 3, they were just totally different numbers. On this first example, I have a 4 and a 6. Now I could use a common denominator of 24, but that's not my least common denominator. So sometimes you can find something smaller. The other thing that we're going to have that you didn't do in the 5th grade is we're going to have a whole bunch of we're going to have a whole bunch of fractions. So looking at this one that has some variables, let's start with the numbers. Let's look at that 4 and that 6 that you have in your denominator. So what's the least common denominator? What's the smallest number they both go into? Well, the answer is 12. That's the smallest number that they will both go into. So I want to make both of those be 12s. So this is going to have to be times a 3, and this is going to have to be times a 2. But you also have to include in your common denominator the variable parts. And so when you look at this one on the left, it has an x squared. So if it has an x squared, then this over here is going to have to end up with an x squared also. So I need to take that also times an x squared. And then you have to look at the y's. This one has y to the first, but this one has a y to the third. So it has y 3 times there. This only has it there 1 time. So I always have to use as many as the biggest one. And so if this wants us to have a y to the third, then I'm going to have 3 y's represented. So over here on this side, since there's only 1 there, I need 2 more of them. So I'm also going to have to take that times a y squared. So now let's look at and see what that gets us. I'm going to go ahead and multiply right here. So that's going to get me a 12y squared over, and on the bottom I'm going to have a 12, and I'm going to have an x squared, and I'm going to have a y cubed because I have a y squared here and also another y to the first. All right, minus, okay, on the top I have an 8x squared, and on the bottom I have a 12x squared and a y cubed. Notice that these are common denominators. So once I have the common denominator, I just merge it together into one big fraction. So it's going to be a 12x squared y cubed. And on the top I have a 12y squared minus 8x squared. Now a lot of the time I'm going to be done there, but what I notice is that I can do some dividing into some things here. And what I see here is, well, I was looking at these x's, but notice that this division bar says the entire numerator gets divided by this. So if I'm going to do any reducing, it's got to go into both of them. So I looked here at this x squared. Well, this doesn't have an x squared. So even though this one does, I can't cross those out. Here's the y cubed. I've got y's here, but I don't have any over here. So those aren't going to reduce. What I really see, though, are the numbers. I've got a 12, an 8, and a 12. And so I can kind of divide those out. Now, I can't do the 12 divided by 12. I really have to find something that goes into all of them. And what I'm really doing is I'm saying in that numerator, I could factor out a 4. And then I'd have a 3y squared minus 2x squared over this 12x squared y cubed. And then this kind of goes back to what we did in a previous lesson when we were multiplying and dividing. Since you're multiplying right here, this 12 is fair game to reduce with that 4 because it's being multiplied right there. So that 4 and 12 would reduce to a 1 and a 3. And so then my final answer, that 1 really isn't relevant then, and I've got a 3y squared minus 2x squared over 3x squared y cubed. And that's your final answer right there. All right, again, a lot of the time there is not going to be reducing. If you would take a minute to go look back at the very original problem, do you see that we had 4's right there? Or this 4 over 6. Those actually, if I had reduced those first, that would have brought those numbers down smaller, and then my common denominators would have actually been smaller, and I wouldn't have had that reducing. So that would be another thing to look for. It doesn't happen very often that the original will reduce for you, but if it does, we might as well try it. Or just do it later, whichever way you like. Okay, let's try another one. Okay, again we have two monomials, so we're looking at trying to get a common denominator between these two things. So I have to find the number, the smallest number, that 2 and 3 both go into. And so that would be 6. So this side times 3, this side times 2. And then you got to work on the variables. And so let's start with the x's. This one says that I need to have an x to the first. This one also needs an x to the first. Well, good, they both have it. I don't need to do anything extra. But this one also has a y squared, and this one over here doesn't have any y's. So I need to take it times a y squared. All right, so once you've figured out all the stuff that you need, then you go ahead and multiply this out. So in my numerator here, that's going to get me a 9y squared. Minus, over here I'm going to have, whoops, let me put that over my common denominator. That's a 6, an x, and a y squared. And then I have minus 8x over 6xy squared. So I have the common denominator. Let's go ahead and merge it together as one big fraction, 6xy squared. And on top I have a 9y squared minus an 8x. Take a minute to see if you can do any extra reducing there. And really the only way there would be to do any reducing would be if there was a GCF of some sort that you could factor out of this that would then reduce with your denominator. And looking up here, there's not a GCF. So I'm done. That's my final answer. All right, let's move on to doing something that has binomials in it. So I'm starting with one here that actually isn't really all that tricky, because if you look here, this denominator is exactly the same as this denominator. It's got the 5, it's got the binomial in it that's the same. So I already have a common denominator. All I have to do is merge it together. And so I'm going to write it as one big fraction with that common denominator of 5 and n plus 6. My numerator, I'm going to combine all of this stuff together, which means also combining like terms. Now I'm in luck on this one because this is a plus sign. Now the next one you're going to have to do by yourself. Take a peek at number 4. Do you see that this plus sign is actually a minus sign? And you are subtracting the entire quantity, so that minus sign would distribute through. Now I don't have to do that on this, it's a plus. So I am just adding up all my like terms. So I have a 6n and a 2n, so that would get me an 8n. I have a negative 2 and a plus 1, that's going to get me a negative 1. And that's all there is. I've got my common denominator, nothing's going to reduce. Done. All right, I want you to try number 4 by yourself. Don't forget the very first thing you should really do on number 4. Well, here, let's look at it. The very first thing you should do is change this minus sign to a plus and distribute the negative through everything in that numerator. Okay, now go ahead and pause the video and finish up from here. Okay, so this is what you should have when you combined this 3 and this negative 2n, that gets you a positive n, and then a negative 2 and a positive 3 gets you a plus 1. The denominator was already alike, so we didn't have to do anything with that. We just merged it together. But here's what's kind of cool about this one. Remember that this is its own quantity up here now with that plus sign, so the only way you can cancel it is if you cancel it all together. But we actually have an n plus 1 on the bottom that could cancel with that n plus 1. So it does have some reducing. You always look for that to happen. Just maybe once in a while you'll get lucky like we did here. Now you have to remember when you cross things off, you're supposed to be leaving like a 1 in their place. So what I end up with is a 1 over 9n. Final answer. Now before we move on, you may want to go practice this a little bit. So what we've done is we've added and subtracted with monomials, and then we've added and subtracted with some fractions that already have a common denominator. So if you wanted to just go practice that for a little bit, you should be able to get through number 17 in your homework, and then come back to the video and we'll add a little bit more to it. All right, let's look at a problem that does not have a common denominator already set up for us. So when I look at number 5 here in our notes, I've got an x minus 5, and remember that as soon as there's addition or subtraction, that's its own thing. And then I have this x minus 4 here, that's its own thing. Those two denominators have nothing at all alike. I mean, it might seem like they're an x there, but that x is caught up in subtraction. So it's similar to when we were adding or subtracting fractions that have totally different denominators. You just take them times each other. And so in this case, so I need to have an x minus 5 and I need to have an x minus 4. So the one on the left here doesn't have the x minus 4, so that's what I'm going to multiply by. And the one on the right doesn't have the x minus 5, so that's what I'm going to multiply by. So then what I'll end up with is an x minus 4 and an x minus 5 as my common denominator. Now, the other thing that I want to draw your attention to here is this minus sign. That's an important thing there because I'm going to be subtracting everything after that. Now, that's more than just the 4 because that 4 is going to have to get distributed through that numerator that I just multiplied by. And so I always find it it's a good habit to go ahead and just change this right away to plus a negative. And then what I'm going to be doing is distributing a negative 4, and so that will take care of the minus sign all the way. Okay, so let's go ahead and work on our numerator. In the first one, we didn't have to worry about it. The 2 just gets distributed. So you'll have a 2x minus 8 plus, and then we do it again on the right side, still have that same common denominator of x minus 4, x minus 5, and on the top I'm going to be distributing a negative 4. So I'll end up with a negative 4x plus 20. Once I've done that and I have that common denominator, it's time to merge these together. So I end up with an x minus 4 with an x minus 5. And on the top, I'm going to combine any like terms that I can. And so what I have is this 2x with this negative 4x. So that's going to get me a negative 2x. And then I have a negative 8 with a positive 20. So that'll get me a plus 14. Or not 14, sorry. That would be a plus 12. All right, and so once I've condensed that together, then I'm done. Go ahead, box in your answer. Okay, so that's how you handle that if your denominators are totally different from one another. Now what I'd like you to do is give number 6 a shot. It's super similar to this one. So go work on number 6, see if you can get through that one. Pause the video, and when you're ready to check your answer, start it back up again. Pause. All right, let's see how you did. I really do want you to take the time to pause and try to do some of these on your own. Watching me do 10 of them is one thing, but actually having to sit there and make decisions and what do I do next, you need to practice that skill as we go through here. All right, so your common denominator, these two denominators are totally different from one another. This n plus 5 is its own thing. This 3n plus 1 is its own thing. So to get a common denominator, you're basically just going to multiply by the other. So then I have my common denominators here of a 3n plus 1 and an n plus 5. On the top, when you multiply, you're going to have to distribute. So I kind of stopped right there. I also changed my minus sign to plus a negative. All right, so really you're just going to distribute on the top. You have 18n plus 6 plus negative 3n squared minus 15n. And then you're able to combine these together with that common denominator and then see what will combine in the numerators. So I usually like to put that in decreasing order of the power, so I'm going to start with my negative 3n squared first, and then I've got an 18n and a negative 15n, so that'll be a plus 3n, and then I have a plus 6. All right, so that's basically my answer. The one thing that I do notice about that numerator is I could factor a 3 out of that. Here's the deal though, if I were to factor a 3 out of it, that would only benefit me if I maybe had a 3 out here that would reduce with it, but I don't have that. So I'm not going to take the time to do extra factoring if it's not going to benefit me. So there's my final answer. All right, let's take a look at this one, number 7. Now, you might approach that similar to how you did the previous one, where the denominators are totally different from one another, but they actually do have something in common. If you look at this first denominator, I'd go ahead and do some factoring on that and pull out a GCF. You could pull out a 3 on that, and you'd have a 3x plus 5. Now, the reason that that benefits me is because when I'm looking for a common denominator, well, I'm going to have a 3, and I'm going to have a 3x plus 5 here. Those are the two things that I've got going on. Over here on the right side, as far as finding a common denominator, I need a 3. Okay, so basically it looks like to cover both of those denominators, I'm going to have a 3 and a 3x plus 5. And what's nice about factoring that 3 out right there is that matches with the 3 that this one needs. So they both already have a 3. All right, so as far as finding that common denominator, they both have the 3. The only thing that's missing is that this side over here doesn't have a 3x plus 5. So I'll take this side times a 3x plus 5. And the one on the left is fine the way it is. So common denominator, 3 with a 3x plus 5. And so that one didn't change, that numerator will stay, plus, and then on the right side I now have a 3 and a 3x plus 5. And on the top I'll have to distribute that 2. Notice it's a plus sign, so no worries about my sign. Distribute and you get a 6x plus 10. Now you have your common denominator. Let's merge that together. Combine like terms on the top. So I've got an x with a 6x. That's a 7x. And then I have a negative 2 with a 10. And that's going to get me a plus 8. And I always take a moment to glance and see if anything could factor. Like, since I have this 3 down here, maybe that could reduce if I factored my numerator. But a 7x plus 8 isn't going to factor. There's nothing I can do. I'm good. All done. All right, let's take a look at number 8. It's pretty similar to 7, but it's got a little bit more going on, so we'll still do this one together. So just like last time, I'm going to look at that first fraction. I'm going to say, what could I factor out of that? And it looks like I could pull out a 3 and an x. So that would leave me with a 2x minus 1. Over here on the right, I've just got that 3. So when I'm picking out what I need for a common denominator, I have to have something to represent each part of both denominators. So in this case, this side says I need a 3. This side's got a 3, so we're good on the 3. This says got to have an x. I do not have an x over here, so I'll have to end up multiplying it by an x. And then the other thing, I have to have a 2x minus 1. I do not have a 2x minus 1 over here, so let's multiply by a 2x minus 1. All right, so what I end up with for a common denominator is a 3, an x, and a 2x minus 1. So on the left side, I had exactly what I needed, no changes in the numerator. And then on this side, notice the minus sign, so I'm going to change that to plus a negative. And probably would be easier if I thought of this negative 5xx as just a negative 5x squared, and then take that and distribute it into the parentheses. So a negative 5x squared, well, let me go ahead and write my denominator here. Okay, so in the numerator, again, think of this as negative 5x squared times 2x. So that would get me a negative 10x cubed. All right, let's do it again. This is negative 5x squared times negative 1. So that'll become a plus 5x squared. All right, last step, let's combine these. You got your 3x, 2x minus 1 for your common denominator. Let's combine what we can in our numerator. If you'll look, there's not a single like term up there, and so I'm just going to write it in decreasing order of the power. So I'll start with my negative 10x cubed, then my 5x squared, and then I'll put my plus 4 at the end. And there's no GCF, there's nothing I can do to make that look nicer. I'm calling it quits right there. Now you could probably go back to your homework and practice a few more, but I think I'm just going to kind of finish out the notes and show you some different things that can happen with these denominators in the process of you trying to get that to be a common denominator. So looking at number 9 in your notes, this one here has an x minus 3. All right, that's kind of its own thing. There's not a GCF that you can factor out, it's just an x minus 3. But on the right side over here, I think there is a GCF we could pull out of that. There's a 3 that could go into both of those, and an x cubed. Okay, so if we pull out the 3x cubed, we'd end up with a 5x minus 2. All right, so now what I'm looking at as far as a common denominator, this x minus 3 is a quantity all tied up together as a group. This quantity right here is tied up together as a group. And then these are individual things. You got the 3 times the x cubed. All right, so here we go. On the left side, this says got to have an x minus 3. So I have an x minus 3 on this side, but I don't have an x minus 3 over here. So let's take this side times x minus 3. All right, then I'm kind of done with the left side. I've got what it needs. Now if we go over here, this one says, I'm going to start with this big quantity just to get it done. It says I need a 5x minus 2. I've got it on the right, but I don't on the left. So we have to multiply the left by a 5x minus 2. Okay. The other thing that the right side has is this individual 3 by itself, not the same as this 3 because this one was caught up in that subtraction. This is an individual 3. Okay, so we need to have a 3. And we also have to have that x cubed. This side says got to have an x cubed. I got it here. I don't over here. So let's also sneak in an x cubed with that 3. Okay, so we have a lot of stuff going on as far as your common denominator. If I were to rewrite this, I would have a 3x cubed, I'd have a 5x minus 2, and I'd have an x minus 3. All of that is going to have to be my common denominator. So let's see what we need to do on the top. Anytime I have monomials, I'm going to probably group those together first. So right there is a 4 times a 3. So that's a 12x cubed. And then the 5x minus 2 is still there. All right. On the right side, I just have to take this 5x times this x minus 3. But looky there, you've got a minus sign. So that means I'm subtracting everything after that. So the best way to handle that is to change this to a plus a negative. And then what I'm going to end up doing is distributing a negative 5x through that quantity there. Now, just to keep it at the same level as the left side here, oops, I'm going to put a plus here, and I'll just go ahead and leave it for right now, a negative 5x and an x minus 3. I could have distributed it. I'm just going to do it all in one shot on the next step. Same denominator. All right, so let's distribute and write this all as one big fraction. So my common denominator is 3x cubed, 5x minus 2, x minus 3. My numerator's going to distribute. It's going to be a 60x cubed minus 24. Oops, that's going to actually be an x to the 4th there. And then a 24x cubed plus, actually I'm going to do a plus, but since I'm going to distribute right here, that's going to end up being a minus. So I'll just write it as a negative 5x squared, and then distribute. The next one will turn into a plus 15x. All right, so if I look at that, I think I got lucky there because there aren't any like terms to combine. They're already in decreasing order, the power. I would maybe look at pulling out a GCF out of the numerator. Is there anything that I could pull out that would go into all of those? And at first glance, I was thinking, oh, not with that 5 there, it's not. But they do all have an x. So I could pull out a GCF of an x. Before I do it, I want to know, is it going to help me? If I have an x factored out, is there going to be an x down here to reduce it with? And I am. Because right here, this x cubed, I could reduce with that. Because remember, if that's just being multiplied in there, that's fair game to cross off. So it is going to benefit me to factor out an x. So I'm going to factor an x out. So that's just going to reduce the power by 1 on everything. And I'm going to cheat again a little bit here. I know that there's going to be an x that reduces. So this 3x cubed is really, I don't know how to write that necessarily that you're going to like it, but if I had an x pull out of that, then it's really going to be a 3x squared now, because that's kind of being multiplied like that. And then the quantity is a 5x minus 2 and an x minus 3. That's all still there. And what I'm going to do then is cancel those x's out. So that just reduced that x cubed that I had, reduced it down by a power. All right, and then I'm going to call that good right there. All right, let's try one more. All right, so how do you think that one went? There were a lot of steps to it, probably the trickiest one we've done. I've got one more example. It's number 10. It's super similar to this one, so why don't you give it a shot without my help and then come back and see how you did. All right, last example. Just another one similar to what we've been doing. I'm going to kind of move pretty quickly through this. Let's start off and factor the right side here to see what we have. You pull out a 3x squared, and what we'll have left is an x plus 2. All right, so when I look for my common denominator, it looks like I'm going to have an x plus 3. I'm going to have a 3x squared. I'm going to have an x plus 2. And so what's missing on the left side is the 3x squared and the x plus 2. And so do that on the top also. On the right side, what I'm missing is an x plus 3. Okay, and before I get too far, since it's a subtraction, I'm going to change that to plus a negative, and so I'll be distributing a negative 6. All right, so here's what I've got then. Remember that we combined the monomial parts. This 6x and this 3x squared are going to get me an 18x to the third. That's going to get distributed to that x plus 2. All over the common denominator. Plus, same thing on the right side, got the common denominator. And in the numerator, again, like last time, I'll wait to distribute and do it all in one shot on my next step. Okay, and now distribute across the top and write it as one big fraction. So I'm going to have an 18x to the fourth plus 36x cubed. On the right side, it's going to be a negative 6x squared, and then a negative 18x. And as a final step here, we'll look to go ahead and pull out a GCF. And on the top, it looks like I really could pull out a 6x, it looks like, is what would come out of that. And I do think that would reduce nicely with the GCF, or the common factor that I have down here. I could pull the 6 out. I could just pull a 3 out and it would reduce nicely. Either way would work. Let's go ahead and we'll pull the full 6x out and see what we've got left. So you pull out a 6x, you'll have 3x cubed plus 6x squared minus x minus 3. That's going to reduce nicely with my GCF in the denominator. So this x will reduce with this x, so I'll only have an x to the first. This 6 will reduce with this 3. All right, so final answer then is going to be a 2 that you may have pulled out or not. If you had redistributed it, that would be fine also. On the bottom, I'm just going to have an x left with the x plus 2, x plus 3. All right, and that's my final answer right there. All right, go back and get to work on the homework problems. Good luck.